This exercise is going to have us use a fork system call to generate multiple children, more specifically n children, n being once again specified by the user when our program starts. But this time, instead of generating children which are siblings and all direct child from the parent process, as this diagram shows, we are going to generate one child from the parent process, which in turn is going to generate another child process, which in turn is going to generate another child process. So this is what would happen for a value of uppercase n equal to 3. Okay, so the way we're going to have something that is really similar to the previous implementation. We're going to have our parent tell us its PID just for reference, ask a value for n, and then we're going to prefix the display from every process, including the parent. Okay, 1308 here. We're going to precede the display of every process in our system by the PID between square bracket followed by a tabulation. That's going to allow us to have a display that looks something like this. For the parent is 1308. 1309 I am generation 1, so this is the first child, okay, from the parent, this one. I am generation 1 spawned from 1308, ready to fork. And we are going to add a couple of sleep with a couple of second delays there. Generation 0 would be the parent. It will indicate also that it spawned a child of PID 1309. So all of this information, when you have the output on the screen, you take a piece of paper, you draw the diagram, and you make sure that the PIDs are corresponding to the parents, the child number 1, 2, and generation number 3. Okay, all right, well, let's move on to the implementation. We're going to start with a code that comes from the previous exercise. Okay, this is boilerplate code here. We have a main function, we have all the include we need, we have here the basic question at the beginning, display your PID, ask for a value of n, and then we have a loop here that is going to fork n children. Okay, for this first version of the program, we are going to use a loop. We are going to design an iterative version of the program to teach you how to exactly manipulate this if-else structure. You know, I am in the parent here, then I am in the child here, in a way that is a little bit different from the previous exercises. So what do we need to do here? Well, every time we fork, first off, you need to understand who is going to have to fork repetitively. In the first exercise, the parent was forking repetitively. In this exercise, the children are going to be the processes that are forking repetitively. So, f equal 0. Where does that correspond to? That corresponds to the child case. So let's start by the parent case, the simplest one, the one where we do not fork all the time. What do we do when we are the parent? Well, first thing, we are going to display our PID here, tabulation, and we are going to indicate that we just spawned a new child process. So generation %d spawned child of PID %d, and we're going to be waiting for it right after that. Let's fill in the blank. The first thing that we need is our PID, then the generation number, then the PID of the child, which is in the return value of the fork system call, which is in variable f. Then we said that we were going to wait for that child, right? So we know how to do that. %rv. Wait system call, we read the exit status of the child process so that we don't have a zombie. And once this is done, we can display on the screen %d, always start every line by your PID so that we know who is talking. My child terminated. I'm done. Difference between this program and the previous one. In the previous one process was capable to generate multiple children. In this case, the parent generates one child, this child generates one child of its own. So every time you are done generating a child, you are going to wait for it, and once you are done waiting for it, you can terminate yourself. Okay, no matter what generation you are. You are generation 0, the parent, generation 1, 2, or 3. So this is a code for the parent process. So we are going to iterate I equal 1, fork. The child is going to do something that we didn't write yet. The parent will display generation 0, spawned child of PID whatever, then wait for it. and once it is done, terminate in turn. So that's going to be the parent. Okay, go back one iteration in the loop. No matter what we did here in the code of the child, if we didn't exit or terminate there, we're going to go back once again for a loop like we did for the parent in the previous exercise, and we're going to create another child process. Meanwhile, child number 1 will be now the parent of child number 2 and will execute this code. Once again, one more time, child number 2 will now execute this code, create a child of its own, and child number 2 will be executing this code, while child number 3 will be executing this code. Take time to make sure that you understand exactly what's happening here and which portion of the code is going to be executed in turn by each process in the tree that is in the exercise description. Back to the code, back to our program. What do we need to do inside of a child process? Well, always a little bit of printf, because that's going to be our first tool to understand what's going on, okay? So display %d, \t, I am generation %d, spawned from %d, ready to fork. So that's all we say in the child, okay? We display our get PID return value, we display our generation number, and we display who we come from with get PPID. We already did that kind of stuff, okay? Then we sleep just to pace the execution for, let's say, 3 seconds. And then what? Once I'm done doing this and this, I get out of my if. I reach the end of my loop, because this condition is going to be false, of course. This condition here will be false for the child. F is actually equal to 0. I skip that if, I reach the end of my loop, I go back, and that's why the child process will be actually executing the next iteration of the loop, whereas in the previous exercise, the parent process was the one executing the next iteration of the loop. Okay, we're going to save this. Let's check it for compilation error first. So we go back to Conqueror. GCC 802.c seems okay. Let's test it. A.out. I'm going to go for 3 children again. So let's have a look at what we have here. I am generation 1. So we didn't start generation at 0 here. We started at 1 directly. Okay, we might want to fix that eventually. I am generation 1, spawned from 922, ready to fork. So this is our first child. We have a parent process, which is 922. Okay, this parent process tells us first, I am generation 1, spawn child of PID 923. So there's a little glitch here. 923 should say, I am generation 2 here, or we should start at generation 0 there. We're going to come back and fix that anyway. But right now, let's see how much is working, how much is broken. The parent, 922, tells us I'm going to fork a child, 923. Then it tells us I'm forking another child, 924. A last one, 925. Hold on a second, I'm picking up the wrong line here, sorry. Generation 1 spawn child of PID 923, yes, that's correct. Generation 2 spawn child of PID 924, and child of PID 924 is generation 3, which spawns another child of PID 925 and waits for it. Every time 924, 923, 922 are going to wait for their child to terminate, and as soon as this child is terminated, I'm going to display my child terminated, I am done. Okay, so let's go review the code, because there is a little bit of weirdness here happening with the generation number. So here is the code. Let's go back here. We iterate from I equal 1, I lesser equal to n, I plus plus. So let's trace that by hand. We start with I equal 1. I am generation number 1, spawned from the PID where you come from. This is what the child is going to say. So when we are here displaying the child is going to be 1 generation below, if you will. So we should display here I am generation I plus 1. Okay, let's take it back from the start. For loop is executed by the parent process. Okay, we enter I equal 1, we fork. So the parent is going to execute this code here, I am generation whatever is your number, okay, and I just spawn the child of PID X, and then I wait for it. The child is going to say I am generation %d, and this %d is going to be I plus 1, so the child is generation 2, and it's ready to fork another child. We go back at the end of the if, skip the next if as a child, go back to the beginning of the loop. This time the value of I is 2, and the child is going to say generation 2 spawn child of PID X. And this new child is going to be generation 3, because we do I plus 1, etc., and so on and so forth. So let's see what it does. We're going to minimize this. Let's get this out of the way for now. And we go back to Conqueror. Compile. a.out. I want free process, and we're going to let it run. I am generation 1. Spawned child of PID something. Okay, this is indeed the parent process talking. The parent considers himself generation 1. That makes sense. Okay. I am generation 1. I spawned my child of PID something. Here is the child that we are talking about. It announces itself as I am generation 2. Spawned from the PID of the parent. So we could start counting at 0. Doesn't matter, that's easy enough to fix. Then we have what? Generation 2 spawned 9 from 933. It's ready to fork. Generation 2 here is at last forking. Forking a child of PID 935. 935 is going to call himself generation 3, spawn child 936. 936 is going to call himself generation 4. So we are getting closer to what we wanted here in the description, except that once again we start at 1 instead of 0. I'm going to fix that in a second. Okay. One thing that we didn't implement yet is the nothing to do terminating. Well, when does this have to be done? This has to be done when you reach this child. This child should not spawn a new child process on its own. It should just display instead, well, I'm done, and terminate immediately. So this is something we didn't include yet in our code. Well, let's go ahead and work on it now at the same time that we fix the start at 0, start at 1 little issue here. So let's start by the easy job. We are going to start counting at 0 here and see what it entails. Okay, we are going to have I equals 0, which means the first parent here will display I am generation 0, and I just spawned a child. This child will display I am generation 1, 0 plus 1, okay, here, and I just came from the parent process. Then this child process will sleep for 3 seconds, keep the next if, go back here, and fork again, and display this time I am generation 1. I just spawned a child, and the child of this first child will go and execute this code here. So that should take care of this issue. The second issue we had was with the I'm doing nothing, I am done. When do I display that? Well, an easy way to handle this would be to say that when we are in the child code, we should test to see exactly how far we are in the generation tree. Okay, let's go back to the description of this program real quick. The tree here tells us that generation 0 is a parent, then generation 1, 2, and 3 are the children. So I iterate between 0 and 3 included. But when I reach 3, I do not do my fork. I just simply say, I am done, I have nothing to do, I'm out of here. So let's modify our loop so that it does this. Right now we start at 0, and if I ask for 3 generation, I stop at I equal 2. So that gives me 0 for the parent process, 1 for the child 1, 2 for the child 2, and we would stop short of 1. So let me put back the lesser equal to 0, but let me also put some code here that is going to test when we reach I equal to n. When I equal 3, 0 is a parent, 1 is a child number 1, first generation, second generation, third generation. When I equal 3, we are dealing here with the last child of this tree. What do? Printf. We follow what is requested of us in the exercise, okay? The PID between square bracket, a tabulation, and we are going to display, let me take the correct phrasing, nothing to do, terminating. Nothing to do, exiting. \n. And I'm going to indeed exit. Let's save this. Let's go back to Conqueror and check how this is faring. So GCC a.out, value n is 3. We have already generation 0, that's the parent, PID 942, right? Generation 0, I created a child of PID 943. This child is saying I'm generation 1, I come from PID 942. That's looking good for now. Next, generation 1 here. This child process, the first child process, PID 943. Generation 1 is telling us that it just created a process of PID 944. This is 944, which claims to be generation 2, that makes sense, come from 943, that makes sense as well. 944, generation 2, tells us here that it just created generation 3 pretty much, PID 945. 945 indeed claims to be generation 3, coming from 944, and is ready to fork. When generation 3 finally execute its code, you see it says, well, I have nothing to do. I am generation 3. I'm exiting. Immediately, generation 2, my child is done. I complete. I exit. Generation 1, my child is done. I complete. Parent, my child is done. I complete. Okay. And because we used the appropriate wait system call, we don't have zombie processes here, but I'll let you double check that by using another console and using PS. Make sure that you double check so that you can guarantee that this program is working properly and cleanly.